Welcome to Make Made Simple. Today we'll be starting with chapter 3, that is rigid bodies and equivalent system of forces. So in this chapter we will study the effect of forces exerted on rigid body, and you will learn how to replace a given system of forces by a simpler equivalent system. So our first topic is what are external forces and what are internal forces. So external forces are exerted by other bodies on the rigid body under consideration. Internal forces hold together the particles forming the rigid body. If the rigid body is structurally composed of several parts, the forces holding the component parts together are also defined as internal forces. As an example of external forces, consider forces acting on a disabled truck that three people are pulling forward by means of a rope attached to the of front bumper. The external force acting on the truck is shown in the free body diagram. Suppose we have a truck here so this is the truck and three persons are pulling on the truck. Three persons are pulling on the truck. So this situation can be uh, can be described as a free body diagram as this. So force F is applied by the three persons here. R1 and R2 are this is R1, this is R2, and this is the weight. Now this situation can similarly be described as if not if, like this three persons are pulling here. This three persons could have been pushing the truck forward. Then that situation also would can be summarized as a force F here acting. So both these situations are same, in which three people are pulling the truck and three people are pushing the truck. So this force F was replaced by a force F here. So the force has been transmitted here. This is called principle of transmissibility. Now suppose this truck Suppose this truck was uh, was pushed above by a jack. That is this force. This truck was a jack was kept here, and this jack pushed the truck upwards. So this jack will the truck will go like this. The truck will go like this. So that is called pivoting about point. Suppose this is A and this is B, then the truck would have been pivoted upon point B. So that is called rotation. So we have defined two things. One is pulling the truck and one is the truck going upward by a jack kept at the front axle. So two things are there: translation and rotation. Translation and rotation. Now we come to section 3.1b. Principle of transmissibility and equivalent forces. Now, principle of transmissibility or of equivalent forces, it says that if we have a body here and a force F is acting here, then this situation is equivalent to the force. If I can translate the force here, so principle of transmissibility states that the condition of equilibrium or motion of a rigid body remains unchanged if a force F acting at a given point of the rigid body is replaced by a force F dash of the same magnitude and the same direction but acting at a different point, provided that the two forces have the same line of action. So this force and this force have the same line of action, that is this. So I can simply translate this force F back here. This is called principle of transmissibility. But the principle of transmissibility has some limitations. Suppose we have a bar here AB, bar A here, AB here, and P1 and P2 are acting here. then we can replace this by P1 P2 P2 P1. This can be done by principle of transmissibility, but in real situation, however, the internal forces and deformation produced by the two systems are distinctly different. Why? Because this in this situation, the P1 and P2 are in tension, are making the body AB in tension. Similarly, if we have P1 here, P2 here, then the body will be in compression. But principle of transmissibility says that P1 and P2 can be can be replaced as shown here. But the body and this body would be under compression. So that is not taken into account by principle of transmissibility. So that's the limitation of principle of transmissibility. So that was all for today. If you have liked the video, please do like the video, subscribe to my channel, and share it among your friends. Thank you.